Hello and welcome in section 4 object detection with YOLO, and in this video we'll get an introduction to object detection and also about YOLO method of object detection. And we'll start with just looking at the difference between image classification and object detection. So in case of image classification, once we have an image, we want to get just a set of classes and probabilities that our image belong to these classes. So in case of this particular image, we would have like class some percentage of dogs or dog. And object detection is a little bit more complex because we want to get a distinct objects for each class, right? So here we can see that each object, each dog on this image is actually separate. So it's much more complex problem than image classification. So in practice, it is similar to image classification, but there are important differences. So we still have as an input, we have image or a set of images like video, and you can consider each frame in the video as an image. Then you have to have some kind of model, and usually it's a convolutional neural network that can actually distinguish between separate objects. And then the big difference apart from the models is also the output, because in this case we have not only a list of objects of detected classes, distinct objects on an image, also with the probabilities that each object belongs to a specific class, we also have their location on an image. So as you've seen in an image before, we have those bounding boxes, we have those locations of those objects. So this is much more detailed problem and more complex problem as well than image classification. But there's a feedback. Because it's more complex problem, it can be even more expensive to train those object detection models than image classification models. And in this case, it pays off to actually get started with pre-trained models. And this is even more important than with image classification models because, I need more time and more resources and more data to actually train a decent object detection system. And there are a few object detection deep learning methods that I actually in use in recent years. So we have all sorts of different versions of region proposals methods. We also have single shot multi-box detector, and we have YOLO. And they each have their strength and weaknesses. They require different set of tools and stuff like that. We won't go into the details of comparing those. It really depends on many factors, but we'll focus on YOLO because it's very interesting approach for a couple of reasons. And YOLO is simply a state-of-the-art real-time object detection system. This method or algorithm was designed to be really fast, and they made it fast by using totally different approach that all of the different methods that I've mentioned. And it's actually became so fast, when you have the right hardware, and this is usually just a GPU, pretty decent GPU or graphical processing unit, it can pretty much work in real time. And this is pretty amazing because it can be used in, self-driving cars and with all those use cases when you need a fast detection. But there are a couple of buts, especially for us if you want to use it, because it originally was implemented using a pretty rare neural network framework called Dark, and YOLO's authors they created this framework specifically for solving computer vision problem, and it's not available by default in Keras. Darkness totally different framework, and it's not based on TensorFlow. It's totally different piece of software. But the good news is that there are ports of YOLO and also Darknet, and we'll actually use one of those ports later on to actually use YOLO. This is the Keras TensorFlow port, and also we'll have to use pre-trained models that are available in the original implementation of YOLO. So what kind of pre-trained YOLO models we have? So the first thing to know about those models is that they need to be converted from the original Darknet version. And our Keras TensorFlow port, it has actually tools that will allow us to do that. And there are a couple of versions of those models depending on the size of the model, speed and accuracy that we want to get. So when you want to get a really fast detection with a small model, you can use tiny YOLO. and this is really a very small model designed for what we can call constrained environments like mobile devices. And there's also the standard version of YOLO, which is pretty big, but also it takes a bit more time to actually make the detection, and the model itself is pretty big as well. And there's also two versions. It's trained on Pascal VOC dataset, and that simply means that we have two distinct classes of objects that we can detect. And also we have version that was trained on Cocoa dataset, and in this case we have 80 classes of object available. And you have to have a look at what kind of classes are actually available in both models, and we'll get to that later on. But just keep in mind that there are different options to choose, and your choice will depend on the problem that you're trying to solve.